Peterson.
Thank you. Okay, so I'm on, obviously. Well, thank you very much for this opportunity to talk with you a bit about our relatively new professional science master's program. And so as I get started, I really would like to just start out by saying that sometimes you get a wake-up call. And so as we're calling people to come in and hear all the wonderful things we have to say at this session, I received a nice wake-up call on Friday. So I was in my laboratory talking to a prospective student and all of a sudden experienced some really gripping chest pains and had, the tingling, radiating, the sweaty palms, the nausea, the whole 9 yards. So on Friday, I left the University of Georgia in an ambulance and spent Friday in the hospital. And I'm fine, turns out, but I had some subtle nudges of I really needed to make some changes early on, like little whispers of, you really ought to this, or little nudges and sometimes shoves. And so the way that we got started with this particular program is that I think our society as a whole really has received a major wake-up call. And in my particular case, I listened to that wake-up call because my brother had a massive heart attack at age 43. And so I just wasn't going to take any chances. And so we spent the morning hearing about a number of different drivers that have really aligned themselves now as really, I don't think we've ever seen this before, at least in my lifetime. I really don't think we've had the political power, the environmental concern, and the economic viability of this true transition away from fossil fuels and away from petroleum products. So I'm not going to spend a lot of time talking about the reasons why we're all here and why we all think this is a good idea, but I really want to emphasize that a number of people are listening to this wake-up call and they're hearing it from their own perspectives, and I think that's what's making this so powerful. So it really is a matter of national security or energy independence. And this is a picture of the Secretary of the Navy, and he was making a speech at the National Clean Energy Summit. And I just want to paraphrase a couple of things that he said. And he said, it makes strategic sense to transition away from fossil fuels because it's costly. For every increase in $1 in a barrel of oil, the US Navy pays an additional $31 million. And then he goes on to say it's costly not only in dollars and cents, but for every 50 convoys of petroleum we bring in, we lose a Marine, killed or wounded, and that's just too high a price to pay. So if you couple that with the fact that a number of companies have been investigating this transition worldwide to an alternative form of energy, and you're just looking at the annual investment in renewable energy, and this is worldwide in US billions of dollars, then you'll see from 1995 to 2005, you saw some modest growth in investments. And then from 2005 to 2010, there was a big jump. And I'm a microbiologist, so I like to say now we're in the exponential growth curve. So as we go from 2010 to 2020, the estimates of investments are exploding. And I don't really have time in this particular talk to illustrate why we're making some of these changes and why we're making some of these investments. And some of them have to do with environmental impacts, and some of them have to do with economic viability. But taken all together, what we're seeing is a massive investment in this transition away from petroleum-based products. And what we saw as our wake-up call for this program was I would get phone calls, and my colleagues would get phone calls daily, multiple phone calls sometimes in a day, looking for students, looking for trained people, looking for graduates about to enter the workforce who had some kind of experience in fermentation biotechnology or in biomanufacturing. Because as these companies, new companies were coming online, and existing companies, like we heard from DuPont this morning, were reinventing themselves, and a number of different mergers were taking place, and there just weren't enough people who had this kind of advanced skill set. And so as we see significant growth in this industry, and we don't see that stopping based on the projected investments, then we will really be remiss if we just didn't speak to this dearth of training in the United States. And interestingly, where the wealth of fermentation training takes place and where universities are known for this kind of training that we need now here is in Denmark and the technical university. So that was interesting this morning. So again, I don't have time to go into the progress of cellulosic biofuels, although I would like to, but there was a recent report that covers about 20 different states and their commercial level, not demonstration, not pilot projects, but commercial level ethanol production that's coming online this year. So I encourage you to take a look at that report if you're interested. It's really quite good. Okay, so back to our program. So we were fortunate in that as we were having this epiphany or listening to this wake-up call about how we were missing the boat in some of our training, the National Science Foundation had a call for proposals for development of new, what they called professional science master's programs. And I have to confess, I didn't really know what that was. I hadn't really heard of them. But some of them have been around for a decade or so. They started with the Sloan Foundation investments. And so we investigated how this training that we envisioned might fit into this professional science master's format. And so the title of our project was From Science to Business in Biomanufacturing, the Missing Link for the U.S. Biotechnology Industry. And so what we envisioned for the University of Georgia was a unique focus on the full biomanufacturing experience. So our students can take coursework in feedstock development and harvesting, and I'll explain to you some of our partners in just a minute. And then we can go all the way through all of the middle steps to the end product. And built in as part of this program and an integral part of the program is very intensive hands-on training, because we wanted our students to be able to own these skills when they left, not just say, yeah, I took a class and I got to punch some buttons on an HPLC or something. We wanted them to be able to even get to the level of taking the machine apart and putting it back together, that level of troubleshooting. So the course itself, or the program itself, includes hardcore science courses like you would take if you were a traditional master's or PhD student. But then we also expect you to hit the ground running with Masters of Business Administration students. So we put you in there with the sharks. Let's see how tough you are. I'll qualify that in a minute. I'm just kidding, business people, but you know what I mean. It's a very competitive environment. The communication's different. The level of performance is different. And the way you conduct yourself is very different. So these are unique individuals that can master all these skill sets. So how is a professional science master's degree different? Well, there's a sincere focus on communication development, so written skills and verbal skills. So the students will write standard operating procedures, and they'll be expected to follow each other's protocols. They're expected to make presentations. They're expected to perform analyses of different types that use software that you would learn in business courses. Excuse me. There's more science and math than you would get in an MBA. There's more professional skill development that you would get in a traditional science program, of course. And you don't really do a thesis per se in this program, but you do an industry-related research project, and then you do a paid internship at the very end. So the idea is that we'll start connecting students with potential employers, and we'll start building their network of interactions even before they get to school. Okay. So at UGA, we wanted to develop this professional science master's idea, and I should mention too, on the previous slide, there's a website called sciencemasters.org. This is a Council of Graduate Schools program. There's a website that lists the professional science master's programs. They have a really nice roadmap if you're wanting to develop your own program. They give you some guidelines for how to go about doing that. And if you want to be a part of their organization, they explain to you what the criteria are. Okay. So again, the program really emphasizes teamwork and the flexibility that you would need on the job in industry. The curriculum's designed to be responsive to industry needs, and we've developed an industrial advisory board that help us develop the curriculum and give us feedback as our students progress through the program. So one of the strengths we have at the University of Georgia is the Bioexpression and Fermentation Facility, affectionately known as the BFF. And Dr. David Blum, the director of this facility, is here, and he has a poster tonight, B2, I believe is his poster number. So if you'd like to learn more about the facility itself, I'd encourage you to meet with David. But I've listed the website here, and this is an internationally recognized biomanufacturing pilot plant. And this was wonderful for us because we could actually plug into this facility, and this is where we do some of the intense higher level training where the students are actually expected to take their work from the bench scale or the lab scale up through pilot scale. So we can go up to 600 liters in this facility with all of the requisite downstream processing equipment as well. So in addition to having this wonderful facility and the idea that there's perhaps some National Science Foundation funding out there that we could go after, we wanted to put together a truly interdisciplinary program. And those of you who have done that or who manage these programs know that if you're the first of one of these, that it's going to take you quite a while to get off the ground. So we're a member of a number of different colleges, the College of Arts and Sciences, College of Engineering, College of Business, College of Pharmacy, Vet Medicine, Warnell School of Forestry and Natural Resources, all that kind of function in their own domain and in their own area. And what we envisioned was something that would really cross the boundaries of all these different disciplines. So that's what we've built. Again, we have buy-in from the Terry College of Business, and we were able to capitalize on their excellent reputation for their MBA program. And they partnered with us and helped us develop a curriculum for our students, but it's really the same courses that their MBA students take. Now, our students don't get an MBA. They have the option of continuing on if they feel like they need to. But they take courses like project management. Well, they'll learn how to cost out the man hours of a project and add some dollar signs and set goals for go, no-go for their projects. And they know how to do a SWOT analysis, and they learn how to use some of the software that MBAs use to manage their projects. So this is a real strong plus for our students to be able to go out in the workforce. And our interns, oftentimes, they're able to be given their own project where they get to use all of the new skills that they've learned and build their own project for their internship. So we were lucky enough to, fortunate enough to receive one of the NSF grants for about $700,000. And most of that money went to support the students. So the students received a stipend and some tuition assistance. Our program is 38 credits. It takes the students between 18 and 24 months to finish the program. And again, the students do an industry-linked research project, sometimes at a professor's laboratory, and sometimes it's actually at the company, usually for proprietary reasons. They do have paid industry internships, and one of the strong suits of our program is the really intensive industry-relevant training. So some of the new courses, I just wanted to highlight a couple of these. You would imagine seeing some of them in any kind of biomanufacturing program, but I wanted to jump down to the bottom and just say something that we found really useful and really quite helpful to our students is that we took the time to develop an interactive software program or software package. And I guess within that package there are a number of modules where we actually contracted with people who do this for a living and said, okay, we want to have the students feel really comfortable with the equipment before we're actually asking them to touch all this stainless steel, because it's a little bit intimidating if you're not used to that. So just as an example, I tried to embed the program and it didn't quite work right, but what you're looking at is just a schematic of one of the fermenter controllers. This is just a 110 liter, I think, size. And the more complex, the more sophisticated your fermenter, the controller schematic tends to look like spaghetti. And when you're trying to figure out, okay, what button do I push and what goes with what and where does that spaghetti end up, then you start to get a little confusing. So what we did, I think there's a pointer here, I can actually point to one thing, is if you're trying to zero in on what is this thing down here, or what is this thing over here, then what you can do before you even see the equipment is you can click on that on the schematic, and then you click on a big picture of the fermenter comes up, and then whatever it is you're trying to investigate further, you can zoom in on that, and when you click on that actual piece of the equipment, then you'll see a description of what it does, and then we also have a video of it in motion, or if it's a sampling port, then of how you would take a sample from it. So what we found is that the students, when they're exposed to this kind of training before they actually take the hands-on course, they're much more comfortable with what we're expecting them to do. There's a lot less hesitation. Understandably, they're more confident, at least theoretically. They know what that piece of the equipment is supposed to do if they've reviewed the software before they come into class like they're supposed to. These guys do, most of them do. So they're not quite as apprehensive. It's been shown to increase the practical test scores because the students, sometimes when you're asked to perform with someone evaluating you right there, unless you really own that information, you get a little bit confused. So in addition to experiencing the hands-on training with actual real live equipment, you can go back and check yourself. And in fact, you can actually simulate experiments and make mistakes like forgetting to adjust your pH, and then you see what happens to your 600-liter fermenter before you actually really waste all that media and make a big mess and cause lots of problems. So we found that to be pretty helpful. So I don't have time to sing all the praises of the wonderful students in this program and the wonderful PhD students who have also taken some of these courses, but I just wanted to hit the highlights of just a couple of students to illustrate the kinds of people who are drawn to this. So this is Jean Pullen. Jean's a professional engineer. She's been a licensed engineer since 1981. She got her engineering degree from Georgia Tech, and she said she was really looking for a practical advanced degree program that was worth her putting her company on hold for a little bit for her to complete the degree requirements. And she said she hadn't found that until she came to our program. So she was really wonderful feedback for us because as soon as she would learn a new skill, then she was able to implement that. And at the same time, she helped bring the other students up to speed because she already did a lot of contract work that was in a similar area. She did a lot of work for the city of Atlanta and still does. This is Mark Cassilis. I'll just profile two other recent graduates. Mark has his BS in biomedical engineering from Georgia Tech, and he graduated this past summer. And Mark had multiple job offers before he even finished, which is wonderful. And you can't possibly read all the details on this, nor will I read it to you either. But part of what we ask our students to do at the end of their internship program is to share with the other students and with the outside community what their experience was like. So I think these will be posted later and you can take a look in more detail. I can send it to you if you'd like. But so Mark's background, I gave that to you. These are some of the courses that Mark took. There are some core courses that you'll see in common. Everyone must take industrial, micro, and biotechnology. That's my course, so they have to take it. But there are some other courses where they have some flexibility. They all have to take ethics. They all have to take a couple of other courses. Most of them take project management, strategic management. And then they do differing types of research projects. So some are in my lab, some are in other individuals' labs in biochemistry or in engineering or in forestry. And so some of the skills that Mark used on his internship was at Meridian Bioplastics. They were actually expanding their capabilities. They had a pilot lab, but they were ramping up. They were just starting to buy equipment for scale up. And so Mark was really helpful to them in helping to size the pipes and design the plant and really do everything that they asked him to do. And Mark also was able to help them translate the pilot scale work into the scale up. And so Meridian was very happy with his performance, and I wish I could have them come. I should videotape their testimonials because it's more powerful when they talk about it. But the way that the people from the program are able to hit the ground running and be productive and be flexible and really think through a problem from a number of perspectives is really powerful and really useful to industry. So the feedback we're getting is that we think we're on the right track. So this is the final student that I'll profile. This is Leonard. Leonard got his BS in microbiology in 2000 from Mississippi State. He's been an industrial microbiologist for 10 years. He wanted to come back to school again. He wasn't sure what exactly he wanted to do, and when he saw the program, he thought it was a really good fit. Leonard did his internship at Novozymes, a major enzyme company, and Novozymes loved him. They called him stellar, and he was just really fantastic. And this was an example where he was able to manage his own project as soon as he got there. And Leonard ended up going to work at Mariel Limited, which is a vaccine production company in Athens, and he received an ORISE fellowship for that work. And this is what Leonard's poster looked like, talking about his experiences and how his continuum of learning spans his formal training, his internship, and what he's doing on the job. And so Leonard has decided he wants to continue to pursue the regulatory affairs aspect of the program. So he's gone on to get his certification in regulatory affairs as well. So Novozymes, this is just a quote at the bottom about the program allows the students to hit the ground running, and please send us more. So again, we think we're on the right track. So the program was designed to be responsive to industry needs, but more than that. It's not like we're saying, okay, industry, tell us what you want and we'll build a program that will give you the perfect employee. It's deeper than that. We feel that if we can develop a program with input from industry where we're helping our students get a strong scientific foundation coupled with business savvy, and there's a potential market and a potential employer right there saying, you know, yes, I like this person, that it's a win-win for everybody. So we continue to meet with our industry advisors. We are listening to what they're telling us that we're doing right. One of the things that they told us that we needed to do a bit better was they would really appreciate it if the students had a really strong background in analytical skills and analytical techniques. So we were able to develop a course in analytical techniques for industrial microbiology and have the students take this course, and we've built that into our curriculum now. And so now the students have the confidence when they go out into their internships, they really own that skill in addition to all the fermentation techniques. And there are sub-disciplines within this broad brush that I'm painting where you could specialize in one aspect of recombinant enzyme production instead of maybe a biofuels product. But I decided not to put too much science in here because I could tell you enough to make it confusing. So there are a number of different kinds of projects that are open to the students, and we like that flexibility. So we welcome the opportunity to provide any more information if anyone desires. The website for the program is just biomanufacturing.uga.edu, and my email is up there. And then we also, I'll come back to that one. We also have an app, So if you have a smartphone and you just want to click on it really quickly, if you just go to the App Store and search for MBB at UGA, it will come up. And if you're a potential employer or you want to hear more about what our internships are like, there are a number of ways we can partner with industries, and it ranges from providing internships to guest lectures to mentoring students. There are all sorts of ways that we'd like to work together. And so with that, I think I'm going the wrong way. There we go. Thank you.
Okay, Joy, thank you. Questions for Joy? We maybe have time for one or two. If you just raise your hand and we can get a microphone to you.
No questions?
I have one,
Okay.
Joy, about, you gave a couple of good student examples of who they are. Do you see, have most of those students been from industry or already had a career, or have they come out of undergraduate? And do you see any trend there? And I guess maybe what I'm leading to is, do you see industry wanting to send more people
Yes.
into the program?
Yeah, something I kind of glossed over is one thing the industry said is they would like to see the opportunity for continuing advancement for their own employees. And so, yes, we have a number of industrial partners who have said we would very much like to send our students, our employees to you part-time. We don't want them to quit. And maybe there are certain things that they don't need because they already have those skills on the job. But the students in the program now are about half with industry experience, half recent graduates. They range in age from 21 to in their 50s somewhere. And they're really diverse ethnically, even split male-female. And I didn't do that on purpose. One of them asked me, did you do this on purpose? It's like you handpicked us to be diverse, and I didn't. They just turned out that way.
Other questions for Joy? Right here in the front.
Hey, I am a student at the University of Georgia. I was just wondering, is there any actual applications on campus of the finished product from the research that you're doing, from the actual fuel that's being made? I know there was a pilot program a few years ago. It was with the buses, for example. Is there anything that your department works with?
This particular program is not just focused on biofuels. So the students, if they're working on a biofuels-related project, they would be in an individual researcher's laboratory. So there would be perhaps applications of that researcher's work. But right now on campus, most of at least the people who work in my lab, if we produce ethanol or butanol, it's in small quantities. And if we need to scale up and use the bioexpression fermentation facility, it's for a specific project, but it's for that company. So yeah.
Okay. All right, let's thank Joy for that great presentation.